Welcome back. I would like to look at one more example of vertical asymptotes before we move on, just to illustrate that there can be more than one. So here I have a function very similar to the one in the previous video, but with the slight difference that this is x cubed minus 3x instead of x cubed minus 3x squared. We don't have a squared there. So the first thing that I usually like to do is factor the whole thing. So x minus 3, and I can factor the denominator. I can get an x out of everything. This is x squared minus 3. And that's about as factored as it's going to get. Now I can't cancel the x minus 3 with the x squared minus 3, so this is in its most reduced form. But we can look at the question of the domain. We can set the denominator x squared minus 3 equal to 0, and that gives us two possibilities, either x equals 0 or x squared minus 3 equals 0. And here I have an equation that I need to solve just a little bit further. This is a quadratic that we could apply the square root method to. So we can move the 3 to the other side, so that's x squared equals 3. And then if I square root both sides, I can get x by itself. So we'll have positive or negative square root of 3. Alright, so our issues, we would say that x cannot actually be any of these numbers, 0 or positive or negative square root of 3. So we have three points of concern, three x values that we want to avoid if we're plugging stuff into this function. Now, since we have demonstrated this is the completely reduced form of this function, doesn't get any simpler than that, then we can immediately tell where the vertical asymptotes are going to be. They're going to be at the zeros of the denominator. In other words, where x times x squared minus 3 is equal to 0. And we already did all the work. We can say there's going to be vertical asymptotes at x equals 0 and x equals positive or negative square root of 3. This is example C on page 649. So you can get a very nice idea of what the graph of this function looks like and see how each of these vertical asymptotes manifests in the shape of the graph. So the next new feature of these rational functions and their graphs is the horizontal asymptote, and we will look at that in the next video.